Hello. Today we're going to be going over Ansible and how it relates to automation and configuration management. More specifically, we're going to focus on Ansible for the network and network configuration changes. Our overview, we're going to be going over configuration management, how it's been a problem in the past, and how we leverage tools such as Ansible to help us solve some of these configuration management problems. We're going to be going over the Ansible control machine, what's required for a control machine, the necessary dependencies, and what needs to be installed, as well as a brief overview on how the Ansible control machine actually works. Because we're going to be using a virtual environment, I am going to go over our lab setup so that you can get a better idea of how things communicate over the virtual network and how Ansible is going to communicate with its managed nodes. We're going to be going over the inventory files. In previous modules, such as Kubernetes, I mentioned that it is not important on how you set it up. It is more important that you just start using the tool. Ansible is the opposite. It is more important that you understand how to set it up, how the documentation is laid out, and how all the configuration files are laid out. We're going to be going over Playbooks, which is what you actually use to run against your environment. We'll be going over the structure of plays and modules, how you take modules and create them into plays, and then how you add the plays to playbooks. Ansible has the ability to do conditional matching and loops, so we'll be going over that and how we can use it when constructing our Ansible playbooks. I'm going to be going over infrastructure as code, which is maybe a term you've heard in the past but aren't familiar with, and it's definitely becoming more and more popular in the world of networking. We'll do a brief demo of Ansible so that you can see an actual playbook ran against Cisco routers. And then finally we'll be going into our summary. Configuration management. It has been a problem in the past because it is not configuration management. It has been a problem in the past as it is that we're going to back up the configuration of our networking devices. Whenever someone makes a change to the network, sometimes problems might not present themselves for some time, and then you need to roll back these changes. So that is why configuration management is becoming so important. We have a couple different solutions here on the board, and each one is unique in its own way. We're going to be focusing on Ansible, which is written in Python. It's agentless, and any Linux machine can be the management station for Ansible. The scripts in Ansible, or the modules, are called playbooks. And then we have a couple others here. It is important to know that you should really try and touch all of them and get familiar with all of them, not just to focus on one tool. But because we are limited in time, I felt, and this is a networking program, I felt that Ansible was the most appropriate. Chef and Puppet are both written in Ruby. They do require an agent on the end host, whereas Ansible does not. So you need to install an agent on the end devices before they can actually be managed. They are managed centrally through Chef. It's going to be the Chef server, and Puppet is the Puppet master. Chef scripts are called cookbooks, and Puppet is called a manifest. And then finally we have SaltStack, which is written in Python. It also requires an agent. The central management is the Salt master, and its scripts used are called Pillar. Here I have push-pull method. That is the difference between an agent and an agentless solution. An agentless solution is going to use the push method where it pushes the configuration to the device, whereas an agent method can actually reach out to its management server and pull the configuration down. The Ansible control machine. Any Linux machine can be an Ansible control machine. The only requirement is that you have Python installed on it and you have Ansible installed on it, which is really not that difficult to get installed. You need Python first because Ansible is written in Python and it is completely open, so if you wanted to write your own modules in Python, you can do that. It leverages the Paramiko library, which is a Python library used to connect to devices using SSH in the command line interface, which SSH is how Ansible communicates with itself in the managed machine. So much like how you start an SSH session with a network device or a Linux machine, that is how Ansible communicates with its managed devices and how it makes changes. As we've discussed, it is agentless, and it relies heavily on YAML for creating its playbooks and plays. Our lab setup. You're going to be using the SDN VM provided by me, and that is going to go on top of your hypervisor. So if this is your home machine, this could be VirtualBox, or it could be VMware Workstation Pro, which I have provided you your license and reissued your licenses to all of you. Our Ansible control machine is going to be the SDN VM. We are going to have to add another virtual network interface card to the Ansible control machine. You can keep adding virtual network interface cards because this is a virtual environment. So through a virtual network, we are going to create a connection between a router and the Ansible control machine in each one of the routers, which is not going to be routable outside of our hypervisor. It is going to be enclosed within our virtual environment. We need to confirm that we have layer 3 connectivity from our Ansible control machine to our virtual routers. Our virtual routers are going to be Cisco CSR 1000Vs provided by me, and some of the basics that you're going to have to configure on it are going to be the host name, a management IP address for IP connectivity, a username and password with a privilege level above 15, which will bypass enable mode on Cisco devices. And finally, we need to configure our virtual terminal line so that we can start an SSH session with our network devices. I added security warning on here at the very bottom so that you know that we are in a lab environment, and the Ansible playbooks that you are going to be pulling down have the username and password in clear text. This is okay in a lab environment where I'm not really concerned about security. In a production environment, this would be a major security breach. You should never store usernames and passwords in your Ansible playbooks like that. You should use things such as the Ansible Vault or exporting your username and password variables when you start Ansible. For our lab setup, we're going to be using the SDN VM, and you're going to deploy this on a hypervisor of your choice. For simplicity's sake, let's go ahead and say that this is VMware Workstation. You're going to deploy 3 virtual routers. The SDN VM, by default, or however you chose to import it, has one virtual NIC, which it then communicates with on the host machines, physical NIC. So there's a couple different ways that VMware allows you to do this, and typically this is going to be NATed to the host machine's IP address. Because we have 3 virtual routers and we're trying to keep this all enclosed, you're going to make another virtual NIC. And each router has 3 virtual NICs. Just because this is a lab environment and I'm most concerned about you being able to use Ansible to make configuration changes on these 3 routers more than I am in our lab environment being able to access the internet, we are going to make something called a host only network, in which case you are going to have another virtual NIC that connects to the host machine, but it is not going to be routable because we are doing a host-only network. So this network is essentially going to be a self-enclosed VLAN, and all these connections are going to be on the same VLAN, therefore they need to be in the same subnet. In my example, in the lab, my subnet was 192.168.470/24, but you can use whatever subnet it is that you want to use. It's just important that you make your host-only subnet different than your actual physical subnet that lives out here. You are going to need to come into the routers under their configuration and change one network adapter to match this host-only network, and then configure the router for an IP address in the host-only network. No shut it. Give it a host name. And enable SSH, local login, and a username with a privilege of 15 so that we do not go into enable mode. Here you can see my 3 routers along with the SDN VM. If I come in here and I go to my virtual network editor, it is going to ask me for admin privileges to change the settings. But you can see right here, I have defined VMnet1 as a host-only network with no external connection, but it is connected to the end host. I enabled DHCP for simplicity's sake for the SDN VM so that it can gain an IP address from within this network, and there's where my subnet is defined. Here, this is all grayed out, because if I wanted to change it, I simply go into change settings, to which it prompts me for admin credentials to change the virtual network settings. And now you can see I have access to change everything that I need to. If I wanted to come here and change my IP address and subnet mask, I could do that here. And I could change my DHCP settings as well. If I come to the SDN VM and I go to Edit Virtual Machine Settings, all of my virtual machines are currently powered off, which is typically how it needs to be before you can make any changes to its configuration settings. I left the network adapter on there for NAT, which connects to the end host IP address and NATs to that IP address, so that I could still have internet connectivity on the SDN VM. And then I simply added another network adapter and I specified it to custom for VMnet1 that I created, which is a host-only network. If I wanted to add another, I would simply come here, click Add, select Network Adapter, and then I could change the settings on the network adapter. And the next time I power on the virtual machine, that network adapter will be present. On my virtual router, if I go into Edit Virtual Machine Settings, I already have 3 by default because this is a virtual router, so it came with 3 network interfaces. I simply came into one of the adapters, changed it from bridged, connected directly to the physical network, to custom, and then specified it for my VMnet1 host only. I'm going to power on the virtual machine, the virtual router now, and the SDN VM to prove that I have IP connectivity between one virtual router and one SDN VM. So I'm going to fast forward while these boot up. The SDN VM is ready, but it takes much longer for the virtual routers to boot up into Cisco iOS. So we are going to have to wait for those to be completely booted up first. Now that my virtual router has booted up, I have previously saved the configuration from running to startup. So we will see with a show IP interface brief command that I have an IP address configured on my Gigabit Ethernet 1 interface. And we can see that it is up and up state. You can see from the terminal that I have configured a host name. Here you can see my username of Ansible privilege 15 and my password. And here you can see I have set login local and transport input SSH to enable SSH on my virtual terminal lines. Coming back to the SDN VM, I'm going to log in. And I'm going to drop a Linux terminal and attempt to ping the router by its IP address that I set statically. With my terminal up, I'm going to do an IP address command, and there you can see my new network interface has gotten an IP address via DHCP in our network range. So if I do a ping to our router's IP address, you can see I am successful because they are both within the same virtual network, which is a host-only network local to just VMware Workstation. Inventory files. So what is an inventory file? Inventory files are files that we use to manage all of our end devices, and here I have a couple of examples on the board. These are host names of IDF switches located in Jacksonville. You're going to have host variables for each device in there, because certain things such as the IP address is not going to be the same across each of your devices. You can group your devices together, and then you can define group variables. Group variables would be things such as usernames, passwords, or operating system type that would not change from device to device, and so you can declare those as a group. You can map variable files to hosts in your inventory file. And it is important to know, with as flexible as Ansible is with all of its variables, since you could have variables in multiple places, Ansible takes the most specific variable declaration, and that one will be used as the variable when it makes its connection. Here you will see our completed inventory file for our virtual network and our lab. I've created a host file and specified the group routers inside of brackets, square brackets. And then I have defined 3 virtual routers under the routers group. VRTR1 through 3, which you can see in my host variable files, I have a file for each one of our routers. They're in YAML format, so they start with 3 dashes. And the only thing that is different between all 3 of our routers is the host IP address. Under group variables, you will see I have a file called routers, which is referenced by our routers group. Same way as the vRouter1 declaration is mapped to the host variable file, because the names are an exact match in the host file as in the host variable file, which Ansible will look in by default for variable information, and the group variable file, which references the entire group, so it applies to all 3 routers. The group variable file is also in YAML format, and you can see the username, password, connection type, which is network CLI, the operating system, which is Cisco iOS. Ansible Become is set to no. What Ansible Become allows you to do is enter enable mode for credentials that don't automatically have the access to enable mode, which is why we set our Ansible user to have a privilege level of 15, because it will not drop us directly into enable mode, but privileged exec mode instead. If this was set to yes because our user did not have those privileges, we could simply automate with yes, and here's our become password. In the host file, when you initially start your lab, you will see all of your variables are located directly next to the router. This is because Ansible is extremely flexible, and there are multiple places that you can put your variables, including in your playbooks, in host variable files, group variable files, or directly in your host's inventory file. You start in the lab by moving all your variables to host variable files and group variable files. In production environment, it is important to know that routers, hosts, can be a member of multiple groups. So although those are also routers, they may also live in a data center, or let's say just two of them do. We could then reference our data center group in the playbook or in group variable files, and it would only apply to these two routers. Playbooks. Ansible playbooks are written in YAML. As you can see here, of an example playbook, YAML files start with 3 dashes at the top and end with 3 dots at the bottom. So this is a full, complete YAML file indicated by those 3 dashes and those 3 dots. You can see everything is in key value pairs, much like in dictionaries or JSON format. However, YAML is less restrictive on its syntax. As you will see, it is far less complicated. YAML is much more strict on your indentations and how everything is grouped together via indentations or dashes. They use Jinja 2 templating. What Jinja 2 templating does is it allows us to store things such as our output in specific variables or things from our output into variables, and using Jinja 2 templating we can call those later in our script. You can have one or more plays per playbook. It does not have to be one play per playbook. And each play consists of tasks, which there could be multiple tasks. Each task consists of modules, which there could also be multiple modules. And then each module has specific parameters that needs declaration in order for the modules to work properly. And you'll notice I did each of these indenting one more line because this would be an example of YAML formatting. Everything falls within the play grouping, and then the next indentation says everything in here falls within the task grouping, which the next indentation says anything here falls within modules, and then parameters falls within the modules. So this is just an example of how YAML also uses its indentations. Here we have a typical Ansible playbook for gathering facts from our iOS devices. The sections of a playbook are this entire thing is the playbook itself. It is in YAML format, as we can see from the 3 dots that start and the 3 dots that end it. You will remember that I said YAML is extremely strict on its indentation. So the first thing we do is name our play, which is what this is. Here we have our connection type set to network CLI. This is redundant as it is also in our group variables file under Ansible connection for all of our network devices. This is where we specify the host that we would like to run the play against. In this case, it is our router's group. So it is going to apply to everything in that group. And it references our inventory file. Here we have a task. and in the task contains multiple modules. So what our play really does, or our playbook, is logs into each one of our routers, grabs the facts, and that is indicated by the module name here, register the output of gather facts in a variable called output, and then our last task down here says to show the output, and it is going to print to the screen the variable output, which contains the return from our collect facts. Plays and modules. Plays are in Playbooks, and as you can see in here, we are starting our play and calling the tasks in here, in which case we are giving each task a name, and then there's more than one module in our tasks. Modules have specific parameters that are outlined on Ansible's documentation website. So if you ever needed to look up what modules require what parameters, you would go to their documentation site, and that would provide you all the information you need to build out your play and your playbooks. Each task and each play can have multiple modules, so you can run one module and then feed information into the next. And then each play can also have multiple tasks. It is most important that you understand all the information to fill out your playbooks and your plays is located on Ansible's documentation website. Looking at our Gather Facts playbook again, we can see that this would be our play, and this is the play name. Under tasks, we actually have two, task 1 and task 2, indicated by their name. In our first task, we actually have two separate modules. You can tell these apart because of the indentation. After the name that indicates the start of the first task, it is equally indented with the name of the module and then the various parameters that the module needs. Below here you can see the indentation moves back and is even with iOS facts and the name indicating that this module is still a part of this task. When we start a new name, that tells us this is a new task, and it is a debug module to print the variable output to the terminal. On Ansible's documentation page, here is a list of all the network modules supported by Ansible, listed by vendor. So you can see we have FortiGates in here, we have F5 load balancers, Cisco iOS, iOS XR, Juniper Junos, Cisco Meraki, NetScaler. Any of them that are supported are going to be on this documentation page. So if we look at the iOS facts module, it tells us what it does. Collects facts from remote devices running Cisco iOS. So if we click the module, it then takes us to the documentation page for that module, in which it tells us what it does and the various parameters needed in order for it to work. You will notice that most of these provider parameters, such as auth pass, the host, password, those are all defined in our host and variable files. This is quite a simple module, so there are not very many parameters that go with it. But here you can see the different examples that you may want to get when you're gathering your facts or running this module. The return values are all values that are going to be returned by the module, and we can then use these return values to store them in variables that are outlined here for another task or another play within our playbook. Conditionals and loops in Ansible. We can store things in variables from outputs from different modules earlier on in our playbooks. We store those in memory, and then we can call them using Jinja2 formatting annotated by the double curly braces. Our with statement specifies that we would like to loop through items in a list. So in this example, you can see with items. So the list is items, and then each one of these is an object in that list, and it will loop through each object in the list. As you can see called up here, item name, item description, name and description, one object would be done, and then the next, and then the next. The when statement allows you to do conditional matching, which is Boolean based, meaning it is true or it is false. So the when statement right here says when vRouter1 is in the output of our standard output, which would have been called from a gather facts module. If vRouter is in there, then run this task and these different modules. With Ansible comes the ability to loop through lists and do conditional matching, much like you would in any scripting language such as Python. So here we have a playbook with a single name or a single play, configure loopbacks conditional. It is a network connection CLI, and it's going to be run against our routers group. Starting at tasks, we can see that we have 3 tasks total. Each indicated by their name. Our first task runs the iOS command module and uses the parameter commands to do a show run include hostname, which will take the output of that and register it in the variable output so that we have the host name. Our next task configures conditional loopbacks. So it runs the iOS interfaces module, the parameter config, and the name in Jinja2 formatting specified by these 2 curly brackets, which is Jinja2 formatting. It is going to use item name, same with description, item description, but it is calling a variable using Jinja2 formatting. The documentation for this module say you have to enable the interface as true or false, and we want to bring these loopback interfaces up and merge the configuration with the current running configuration. It is a little bit backwards in Ansible because it is not going to run this unless this condition is met, and that is indicated with the when statement. So it is saying when vRouter1 is in the output of our standard out, which references this meaning if this is the name of the router from this command, then it will run the iOS interfaces module. The with statement indicates looping through this list that we created. We have given the loopback interface a name and a description. Here we have 3 items in our list, name and description, which are all parameters for the iOS interfaces module. So instead of having everything underneath the config line, we create a list of variables and then call them using Jinja2 formatting, in which it says item name, and in our list to loop through the items, it is referenced by items and then the name, item description, item description. So this value will be placed here first, this value will be placed here first. Once it has ran that module using these values, it will run the module again with these new values, and then run it again with these new values. Finally, we are going to register our output as show output so that we do not overlap with that output. And then our third task is going to show output by running debug and printing the variable show output to the screen. And then this ends our playbook. Infrastructure as code is becoming quite popular because it no longer means that we manage devices and change configurations device by device. Instead, what we end up doing is building out configuration templates for a specific model of device, and then the things that change from device to device, which we would say are the host variables, are called from variable files, and then they are called via the Jinja2 template formatting. So instead of managing configurations on the device locally, device by device, we manage a big library of configuration files and device template files, which reference the different variables for each device. We also leverage Ansible roles, which are going to be a little bit outside of the scope of this course, but it is a basic theory in Ansible, so if you would like to read more on it, please go to their website. This allows us to automate changes to our network. So instead of getting up late at night to make all these changes to a production environment, Ansible would simply push all of our configuration changes for us. And if something breaks, we can simply roll back to the last configuration revision. This is where Git also comes in very heavily, because we can use version control systems to monitor the changes in both our configuration files, our device templates, and all of our variable files. I'm now going to go over a brief demo of using Ansible and running some playbooks. So the first thing I'm going to do is list all the contents of my directory. Here I have already set up my host file. There you can see the routers group, as well as the host variables file, and the group variable file. I have powered on all 3 of my virtual routers. So I'm going to examine my router facts playbook. And you can see that it collects iOS device facts against our routers group, runs 2 tasks, collects the facts, registers the output, and then displays the output to the terminal. So I'm going to run the command Ansible, Playbook, router facts. You can see the play starts, collect iOS device facts, and then it starts the tasks. There was 3 routers, so quite a bit of output. But here you can see the first task is gathering facts, collecting the facts. And it says OK on all 3 of my virtual routers, saying that it was able to connect and run gathering facts against all 3 routers. It was able to collect the facts on all 3 routers, or register them, and then it prints the output to the screen, which is all the facts for all 3 of our network devices. At the bottom, it gives you a play recap of how your playbook or your play ran in each one of the hosts that it ran against. This is simply gathering facts, so it returned a OK. If this was a configuration change and a change was made to any of our devices, you would see that it lists it as changed here. If there was any problems, such as the router was unreachable, it would list that. So to demonstrate the difference, I'm going to power off one of my virtual routers. And I'm going to run the playbook again. As you can see, it took a little bit longer for the playbook to actually run, because it was trying to contact the 3rd router, which was not able to be contacted. Therefore, it failed. In summary, we've gone over configuration management, the Ansible control machine and all of its requirements. We've looked over your lab and your lab setup. We've gone over the inventory files, playbooks, plays, and modules. And then we looked at conditionals and loops within Ansible and how we can leverage those. And then we briefly discussed infrastructure as a code in theory, and we demoed Ansible against our CSR 1000V routers. If you have any questions, I do wish that you direct them towards the discussion boards so that everyone can participate. Otherwise, you are more than welcome to reach out to me. I hope everyone enjoys the lab on Ansible, and I hope you have a great rest of your week.